differential equations. Okay, so here's definition. So a differential equation is basically an equation that relates a function with some of its derivatives. That's all it is. For example, x y prime plus y equals x times 3x plus 4. Okay, so this is a differential equation because, as you see, I have function y and I have y prime also in the equation. I have y and y prime being the derivative of y. Okay, so that's a differential equation. Another one, 2y y prime plus y prime cos y is equal to 6x2. Okay, so these are differential equations. Okay, they're first order because there's just one prime. There's no prime, just the first derivative. Okay, there's many more you could go. You could do different orders as well. Okay, more higher order differential equations. We'll just do, I think, in this course, first order separable equations. You will see. Okay, now a solution, a general solution. No, sorry, not A, means the general solution. Of a differential equation is the set of all functions that satisfy the equation. Okay, so here's an example. So let me see. Y equals to x2 plus 2x plus c over x a solution to this differential equation, which is x y prime plus y equals x times 3x plus 4. Okay. So I want to know if this function here, y equals x2 plus 2x plus c over x, is a solution to this. Okay, so how do you suggest that we proceed?
Maybe take the derivative of the function.
Very good, and then?
I'm not sure.
What?
I'm not sure.
Good, so you take the derivative of the function, you'll find what y prime is. You're going to plug it in here. Then the y, I want to plug it in here. I'm going to see when I simplify if I get x times 3x plus 4. Make sense? I just need to verify that this works. So let's find y prime. So y prime is 2x plus 2 minus c over x2. This is what y prime is. And now I'm going to replace y prime in here and y in here and see what I get. Okay, so x y prime plus y equals 2 x times, so y prime, which is this, 2x plus 2 minus c over x2 plus y, which is this.
So you wrote minus c over x squared. How did it become minus?
Because the derivative of c over x is negative c over x2.
Okay, sorry.
No problem. So plus y, which is x2 plus 2x plus c over x. Okay, let's simplify things here. I get x times 2x is 2x2 plus 2x minus c over x plus x2 plus 2x plus c over x. That's what I get. The c over x's cancel. And what's left? 3x2 plus 4x, which is x times 3x plus 4. Perfect. Do you get it?
Can you go over it again? So, what you did in like the second.
Example is y equals c times e to the power of x minus x2, a solution to the differential equation y prime plus 2x minus 1y is equal to 0. So let's go, let's find, we need y prime. So y prime is equal to c times the derivative of the inside 1 minus 2x e to the x minus x2. And so y prime plus 2x minus 1y is equal to, so y prime is c 1 minus 2x e x minus x2 plus 2x minus 1 times y, which is c e to the x minus x2. And this, if you simplify, you're going to get 0. It's going to work. Okay, so this function is the solution to this differential equation. Do you have any questions? Okay, so that's the first step, is identifying whether a function is a solution to a differential equation, okay, a function or a set of functions. So now I'm going to obviously ask you to find the solution. Okay, so finding the solution. Okay, so we're only going to deal with what we call separable differential equations. So let me define a differential equation. Is separable if it can be written as, okay, so I'm going to explain in a second, f of x dx equals g of y dy, okay? Solve instead of running solve, I'm going to say find the general solution of, okay, so let me give you an example of what I mean by this. Y prime equals 2 e to the x plus 2y. Okay? So now I want to solve this differential equation. So y prime is dy dx. This we know. Okay, y prime is the derivative of y with respect to x equals to e to the x plus 2y, which is the same thing as e to the x times e to the 2y. Okay, good. Nothing too crazy here. And now I'm going to multiply the 2x, I'm going to send it up here, the dx, I'm going to send it up here. And the e to the y, the 2y, I'm going to send it down here. So this could be reduced as, simplified as dy over e to the 2y equals e to the x dx. Okay, or if you prefer, e to the negative 2y dy equals e to the x dx. Okay, so it's separable because I managed to put all the y's with the dy and all the x's with the dx. That's why it's called separable. I managed to separate the x and the y's. Okay, that's not always the case. Okay, but in this course, we're only going to deal with things that behave this way. Okay, so if you're on the test and you can't separate them, then you made a calculation mistake for sure, because I'm going to make sure that you could do this. Okay, at this point, I'm just going to integrate both sides. Two very easy integrals.
Sir,
Yes?
now At the first step, you just try to like find the derivative of y.
The first step?
Yeah.
What do you mean I'm trying to find here?
Like, yeah. What
I
is
just
it?
rewrote it.
Okay.
Instead of writing y prime, I wrote dy over dx.
Oh, okay.
Okay, so I did. Okay, so let's do the antiderivative of e to the negative 2y. So this, I'm sure you're very good at this now. So it's e to the negative 2y over negative 2 equals, and the derivative of the antiderivative of e to the x is just e to the x, and plus, of course, a constant. Okay, which I could put on the left or on the right, or I could put two of them and combine them. Who cares? I'm just putting it on the right. But it doesn't make a difference. Just put it on the right so we all do the same thing for convenience. And now what I'm going to do is I'm going to isolate y. So I will multiply by negative 2. So e to the negative 2y equals negative 2e to the x minus 2c. And then I'm going to take ln of each side. So negative 2y equals to ln of negative 2e to the x minus 2c. And so y is equal to negative a half ln. Could you still see? Yeah, you're going to cut. So I'm just going to write it on top here, or below. I don't know if I could squeeze it here. Can you see? Y, yeah, you could see. Y equals negative 1/2 ln negative 2e to the x minus 2c. That's my general solution to this differential equation. Okay, this function here satisfies this differential equation. So try this one here. Y squared minus xy is equal to 0. Sorry, not x squared, x prime, sorry. Not x squared, x prime. So y prime is xy, which means that dy dx is xy. Send x here, the y down here. Dy over y is equal to x dx. And then I'm going to, now that it's separated, I integrate both sides. So ln absolute value of y is equal to x2 over 2 plus a constant. And therefore, if I isolate y is equal to e to the power of x2 over 2 plus c. That's my answer. Usually what we do at this point is we go like this, times e to the c, okay? And then e to the c, I'm going to call it a new constant k. Okay, so we write it like this. K constant times e to the x2 over 2. That's it.